Now let's look at 2024 AIME I Problem 3. This problem says that two people, Alice and Bob, play the following game. So we have a stack of int tokens, and each turn, one person removes either 1 or 4, and they alternate. So we need to find a strategy that finally Bob wins the game. So whether such a strategy for Bob exists. Okay. So it asks us to test the scenarios in terms of the number of tokens that ranges from 1 up to 2024. So among those 2024 numbers, which ints lead to the scenario that Bob could develop a strategy so that irrespective of what kind of strategy his adversary Alice takes, Bob could always win the game. So for this problem, we can observe the following fact. Because in each pair of move for Alice and Bob, okay, so it's 1 or 4. We can easily think about the sum is equal to 5, right? So that might give you some idea to solve the problem. Okay, so in terms of the sum 5, right, for the total number n, so we can discuss 5 different cases in terms of the remainder of n divided by 5. To make our subsequent analysis to be rigorous and clear, so let me also introduce the following notation. Okay, so let me use A sub I to denote the Alice ith move, and let me use B sub I to denote Bob's ith move. So then when we describe our strategy, so we can use the mathematical and the expressions rigorously. Okay, so we discussed those 5 cases. For the first case, it is for n that is a multiple of 5. Actually, for this scenario, Bob can easily come up with the always winning strategy, how it works. So for each ith move for Alice and Bob together, so Bob can always play the strategy that bi is equal to 5 minus ai. So basically, in each turn for these two people, so if Alice chooses 1, then Bob chooses 4, or vice versa. So basically, after each pair of moves, we know that the number of tokens is decreased by 5, right? Because in this case, n is a multiple of 5. So finally, we will have 5 tokens left over, and then Alice moves first, and Bob will remove all remaining tokens. So this leads Bob to always win. All right, so now let's see how many ints fall into this case. So we have 2024 can be written as 5 times 404 plus 4. Therefore, the number of ints in this case is 404. Then let's look at the second case, that n is congruent to 1 mod 5. Actually, for this case, Alice exists the strategy that for any strategy Bob plays, Alice could win the game. How it works? So it's very easy. Alice will always first take 1 token. So let's think about it. So after Alice initially removes 1 token, the number of remaining tokens is a multiple of 5. So the problem goes back to the above one, case 1 problem, right? So case 1 problem tells us that if the number of tokens is a multiple of 5, then the player who moves later exists the strategy to always win the game. So here, in this scenario, right, after Alice first removes 1 token, so for the remaining problem, it becomes that Bob moves first. So Alice can simply adopt the strategy we developed above. Or let me make it more precise. So basically, for A sub I, it is simply equal to 5 minus B I minus 1. So this guarantees Alice to win the game. Therefore, for this case, there's no way for Bob to have a strategy that guarantees him to always win the game. Okay. Then we look at case 3. It is n is congruent to 4 mod 5. So this is analogous to case 2. So Alice can adopt a similar strategy that guarantees her to always win. So her first move is 4. And that makes the subgame to be with the number of tokens that is a multiple of 5. So we know for this scenario, the player who moves first may lose the game, and who moves the second uses a strategy to always win the game, right? So to make it more rigorous, then Alice takes the strategy that for her ith move is equal to 5 minus the number of tokens that Bob takes in his -1 move. Okay, so in this case, Alice has a strategy to win the game, but it's not true for Bob. Okay, then we look at case 4. This is for n is congruent to mod 5. So for this case, Bob may consider to take the same strategy as case 1, that n is a multiple of 5. So given this strategy, let's think about it. So after both Alice and Bob complete their ith turns, we know that the total number of tokens is reduced by 5, right? And in this case, n has remainder 2 divided by 5. So it means that finally, there will be 2 tokens on the table. When there are 2 left over, Alice needs to move first. But we know that Alice can only take 1 or 4 tokens, but there are only 2 on the table. So the only choice for Alice is to remove 1 token. And now it's Bob's turn. So Bob just remove the last one. Then Bob wins the game. Okay. So in this case, Bob exists as a winning strategy. So let's count the number of ins that fall into this case. So recall that we write 2024 in such a form, right? So the quotient is 404 and the remainder is 4. Therefore, for this case, for n that has remainder 2, the number of solutions should be 405. Okay. All right. Finally, let's look at case 5. That is n is congruent to 3 mod 5. So for this case, let's consider Alice's following strategy. So Alice begins with taking out 1 token. So now we know that the remaining number of tokens has remainder 2 divided by 5. So as what we just studied in case 4. So in this case, right? So the second player has a strategy to always win the game. So basically now, Alice becomes the second player for the remaining game or sub game. So basically, Alice has a strategy to always win. Okay, to make it more rigorous. So for Alice's ith move, it is equal to 5 minus the number of tokens that Bob takes in his -1 move. So finally, there will be 2 left over. And in such a situation, we know Bob needs to move first. And Bob takes 1. And then Alice will take the last one. Alice wins. Okay? All right. By putting all cases together, we notice that Bob exists the winning strategies for only case 1 and case 4. So by putting these 2 cases together, the number of ins that leads Bob to have a winning strategy is equal to 805.